Everyone, welcome to lesson 7. We're going to look at rational exponents today. And before we start, let's just do a quick review on our exponent laws. So first of all, I have the product law, x to the power of m times x to the power of n. This would have me taking the sum of my exponents for x to the power of m plus n. The power of a power law tells me I need to multiply my exponents. So to simplify, this would be x to the power of m times n. The power of a quotient would have me doing something very similar where I need to distribute the exponent into my base, the numerator and the denominator for x to the power of m divided by y to the power of m, where y cannot be equal to 0. And then I have the integral exponent rule, which tells me that in order to make this negative exponent positive, I need to take the reciprocal of it and rewrite it as 1 over x to the power of m. And the quotient law, I have x to the power of m divided by x to the power of n, where I would be subtracting my exponents. And then I have the power of a product law, where I distribute my exponent into both of my variables for x to the power of m times y to the power of m. And then last, we have our rational exponents, x to the power of m divided by n, which we could rewrite as a radical where n becomes my index, and I could write my m as my exponent. And I could also write this in brackets where I take the radical, n remains the index, x becomes my radicand, and then I have the whole thing raised to the m power. So let's take a look at class example number 1 and 2 and 3, and I'll just do a few of them. So first of all, we're going to write each power as a radical. So as a radical, I have x to the power of 1/6. This would be the 6th power of x, and with an exponent of 1. Negative y to the power of 5 over 4 would be negative the 4th power of y to the power of 5, or sorry, index of 4. So 4th root of y to the power of 5. Let's see if any of these look particularly tricky. Actually, let's do this one next. I have negative z to the power of negative 5/3. So first I would make this into a positive exponent by putting it all under 1 to the negative 5/3. And I realize that it's probably hard to read. Sorry about that. But I would make this 1 over the, and this is positive now, the cube root of negative z to the power of 5. And this last one, positive exponent still, but we would have the 4th root of 5t, and I could make that cubed. Now, class example 2, we want to simplify the following, and we want to write each expression as a power with positive exponents and then as an entire radical. So here we have our product law, and so x to the power of 3 over 2 times x. Now, with something like this, we need to add our exponents. So this is going to be x to the power of 3 over 2 plus 1. And just as a little aside, when we are adding fractions, so 3 over 2 plus 1, if it's helpful, you can do these asides and think about your common denominators. So 3 over 2 plus 2 over 2. So 1 is equivalent to 2 over 2. And with fractions, we just add straight across the top for 5 over 2. So this is equivalent to x to the power of 5 over 2. And now we want to rewrite as an entire radical. So as an entire radical, this is going to be the square root of x to the power of 5. I'm just going to change my pen here. Now for this next one, we have y to the power of 1/3 divided by y to the power of 5 over 3. This is equal to y to the power of 1/3 subtract 5 over 3. Here we are going to have our exponent, which is going to be negative. So this is going to be y to the negative 4 over 3. And we want to express this to be positive, which would be 1 over y to the power of 4 over 3. And now we can express it as an entire radical, which would give me 1 over the cubed root of y to the power of 4. I'll just skip this one. This one should be pretty straightforward, but let's take a look at this one here, d. So for d, I have x squared divided by y to the power of negative 1 over 2. Now, when you have your exponent outside the brackets like this, one way to make this positive is you put the whole thing under 1, but then you're working with like a fraction and a fraction, and sometimes that can be confusing. So what we could instead do is we can take the reciprocal of this entire statement, and this would become y over x squared to the power of, now it's positive 1/2. So notice I just flipped my y and my x squared. Now we can take this and we can rewrite this as a entire radical. And so we could also say that this is equal to the square root of y over x squared. Or we could say this is equal to the square root of y over the square root of x squared, which would just be equal to the square root of y over x, because this exponent and the index would cancel each other out. Now let's look at class example number 3. We want to simplify the following. We want to write each expression as a power with positive exponents and then as an entire radical. So exact same thing we were just doing. This time we have a few constant terms thrown in there and coefficients thrown in. And so with these coefficients, let's go and solve these. So just a reminder, when we're multiplying these mixed numbers here where I have a coefficient, a variable, and an exponent, I can simplify right off the bat by going by multiplying the coefficients by the coefficients. So 4 times 3 would give me 12. And then I can combine my, my variables. So this is going to be 12 times x to the power of 3 over 4 plus negative 1 over 2. And again, if it helps as an aside, because sometimes it's hard to see how 3/4 plus negative 1/2 is equal to, let's say, a quarter. So as an aside, if you go 3 over 4 plus negative 1 over 2, we would go 3 over 4 plus, find our common denominator, negative 2 over 4. And now we can see a little bit easier how this is equal to a quarter, because I just go 3, add negative 2, or 3 subtract 2 is 1, and then our denominator remains the same. So this would give me 12x to the 1/4. Now, only the variable is attached to this exponent, and so when I turn this into a radical, I'm only taking that and turning that into the radical where we will have a mixed radical. So the 4th root of x. And next one, I think the trickier one would probably be C. So let's take a look at this. First of all, we have our power of a product law and power of a power here. So let's take this 4/3 and we'll distribute it into everything. So from here, I get 8 to the power of 4 over 3, and then I'm multiplying that by a to the 1/2 times 4 over 3. Oh, I don't know why I have that second bracket there around nothing, but I'll just get rid of that. So 8 to the 4 over 3, let's turn this into our cube root of 8 to the power of 4 times, and then I have, so a to the power of 4 over 6, which we will simplify. Now 8 to the power, or the cube root of 8 to the power of 4, cube root of 8 is 2, and then I have, so this is equivalent to 2, and 2 to the 4th power would be 16. So we can simplify this right away to be 16. And then we would have a to the power of 4 over 6, and 4 over 6 simplifies to 2 over 3. Right? So that's equivalent to 2 over 3, which would be the cube root of a squared. And this would be our final answer. Now let's take a look at a few on the other page. We're looking now at class example number 4. And so we're using this, our rational expression law here, and we want to write each radical as a power in the form a to the power of n, where n has to be an element of a rational number. So let's turn these into exponents. And I'll just do I'll do this one and this one over here. So this is going to be a to the power of 5 over 3. The exponent becomes the numerator, and the index becomes the denominator on my base. With this one here, this is going to be equal to 1 to the power, 1 over a to the power of 7 over 2, which is also the same thing as a to the negative 7 over 2. So either one of these is correct. Class example number 5, we want to write as a power and evaluate. So square root of the square root of 1,296. Now, before we evaluate, let's write these as a power. So this is the same thing as 1,296 to the 1/2 to the 1/2. And if we punch this into our calculators, we can simplify this even to 1,296 to the 1/4. And if we punch this in, this is equal to 6. Again, we'll turn this into a power. We have 1 over 169 to the power of 1/2, or 169 to the negative 1/2, which is equal to, well, is the square root of 169, which is 13. So this would be equal to 1 over 13. And then I have the cube root of the square root of 64. So if we turn this into exponents first, 64 to the 1/2 to the power of 1 over 3. This would be 64 to the power of 1 over 6, which would equal, well, the square root of 64 is 8, and the cube root of 64 is 2. So if you punch this in your calculator, it's going to be equivalent to 2. And I'll just do 1 or 2 of class example number 6. So write each expression in the form a to the power of x to the power, or a times x to the power of n, where a is an element of integers and n is an element of rational numbers. So first of all, we can write this in the form of a to the power of x to the power of n, versus a times x to the power of n, sorry. This would be the cube root of 8 times the cube root of x to the power of 5. The cube root of 8 is equal to 2. And x to the power of 5, we could cube root of x to the power of 5 is equal to x to the power of 5 over 3. Let's do the same thing for b here. This is the 5th root of 32 times the 5th root of x cubed. 5th root of 32 is 2. And 2x to the power of 3 over 5. And I'll just do one example from 7. Let's do this one here. Class example 7c. Now, we can simplify this as an equivalent expression using exponents only. So first of all, if I want to simplify this, this is going to be x to the power of 5y cubed to the power of 1/4 times 3/2. And this is going to equal, if I redistribute the 1/2 first, or actually, let's take care of these exponents, where I would multiply this. This would be 3/8. So we would have x to the power of 5, y to the power of 3 times 3/8. And then I can distribute this into both of my exponents. This would be x to the power of 15/8, y to the power of 9/8.